Welcome to Open Source Options. In the previous video we've looked at how to download Sentinel imagery and how to visualize that imagery in different ways. Now I want to show you how we can actually quantitatively analyze that imagery. So for example, here we're looking at a color infrared image. And what this is showing us is in red, it's showing us where we have healthy vegetation, which would appear green in a true color image. What we don't have here though is we don't have a objective way to quantify how green or how healthy that vegetation is across images or across time. So that's what I want to do today is show you how we can use remote sensing indices, specifically the Normalized Difference Vegetation Index, to get numerical information out of these satellite images. So let me start off by showing you how I have this symbolized. If you watch the Sentinel visualization uh, video from last time, you'll know how to do this. But I just have this set up as a virtual raster with all the Sentinel bands in it. And then I have Sentinel band 8 displayed as red, band 4 displayed as green, and band 3 displayed as blue. Okay, now I'm referring to the Sentinel bands, not necessarily the bands in the virtual image. And let me see if I can pull those up for you really quick here. Let's just go to the internet, and we're going to need this anyway, so let's look at Sentinel 2 bands. And we want spectral bands. Let's actually see if we can find the Copernicus website. I don't see it. We'll try Wikipedia and see how well this does. Okay, so here we go. So this tells us that band 1 is blue. It gives us the central wavelength in nanometers, and it gives us the band width in nanometers, okay? And it also gives us the spatial resolution. And so these are the bands we're working with. We can see band 8 is near infrared. We can see band 8A is also near infrared. It's a slightly different central wavelength, and it has a narrower band width. We could use that one in place of band 8 for specific instances if we needed to. All right. Okay, so we're going to come back to this because, well, we might come back to this, but this is the information you're going to need to do some of these things. All right, let's go back over to QGIS, and now let's calculate our normalized difference vegetation index. Also, it's all greenness index, which it will be referred to sometimes. And the way we're going to do this is we're going to perform a calculation using the raster bands. We're going to take two raster bands. We're going to take the near infrared and the red, and we're going to do some math on them to get one value out that will give us a number representing how green a pixel location is. So let's go to raster and raster calculator. I'm going to close this real quick and just show you if we search for raster calculator in all the tools here, we have three options. We have the Google, and then we have two QGIS options. I can never remember which one I want to use. The one that I prefer is the one here under raster calculator, so that's where I'm going to go. Now I'm going to write this equation out for you down here, just so you can see what it is. What we're going to do is we're going to take near infrared, subtract red, and divide by the near infrared plus the red, okay? And what this is doing, let me explain this. So we're taking, so healthy vegetation reflects near infrared light and absorbs red light. So when we look at healthy vegetation, we're going to see a high response from near infrared and a low response from red. So what this is doing is getting at that. We're normalized, so we're subtracting, we're finding out the difference between the near infrared and the red, and then we're dividing it by the total reflectance of those two bands. So this metric is going to range from -1 to +1, with values closer to 1, larger values indicating more greenness. Okay. So the way we do this, we just replace the bands with these numbers I've written in here, or with these near infrared and red designations I've written in here. So we can do this. We'll just double click here. We'll replace this with band 8. We'll replace this with band 4. And again here with band 8. And again here with band 4. Okay, now we have the equation set up. The next thing to do is to select an output layer. If you would like, you can create an on-the-fly raster instead of writing it to disk. I'll write it to disk just to show you how that works because you may want to do further analysis. But you can click this and you can give it a layer name. Here, I am going to save this, and I'm going to save it here to Sentinel-2 NDVI. I created a test before I did this just to make sure things worked out. So yes, let's replace it. And the next thing you may want to adjust, we will not adjust it here, is the columns and rows. This is how you will adjust the spatial resolution of your output raster. As you notice, some of these bands have different resolutions. Some are 10 meters, some are 20, and some are 60. Here, we've used two bands that are both 10 meters. My output should be 10 meters, so we're going to leave this as the default, and then you can adjust your output CRS. Let's go ahead and run this now. This will take just a minute to calculate, and then it's going to give us load in that raster. Okay, there it is. Everything is complete. We can close this message. And now let's just go in and take a quick look at this. One thing you may want to do is use the value tool. This is a QGIS plugin. You can download it from the plugins repository. And I've got it over here as a panel. This is a very useful tool. It will show you the value for any raster that you have loaded in, all the bands of that raster, anything that is active. I'm going to turn this virtual raster off just so we can see just the Sentinel-2 NDVI values. Let's come into this area over here where we have some variation. We can see here that in this river, I have a negative NDVI value. We can see in this field, I have a value around 0.65. And we can see that in this valley bottom and the river bottom, I have values ranging from 0.4 to 0.5 roughly. And then in between, in this fallow field, we have a value of about 0.1. So we can see how numerically this starts to pick it out. And with a single value, we can describe vegetation greenness. Now we can also go in and do some layer styling, and we can give this single band pseudo color, and we can give it like a red-green color ramp. And now we can see that where things are green, it's green. Vegetation, where things are red, it is not green vegetation. It is, water here specifically. And so we can do that and get a nice visualization of where the greenness is. And you may want to adjust these colors and classification a little bit to show your specific places of interest. Now, the great thing about this, which we are not going into right now, is we can start to analyze images through time. So if we have NDVI at multiple times, then we can start to compare NDVI at a location in early spring across years, or from early spring to late fall, and see when that greenness peaks. Another thing we can do as a comparison tool, if we have multiple images, we can open up our properties here, and we can come to the histogram, and we can click compute histogram, and this will show us the distribution of pixel values across our raster. So we can see there's a spike here right around 0. I expect that is from water, and then we have another spike of values around 0.2, and it slowly starts to taper off. If we looked at two different images, we would likely see different histograms. So if we took an image from December and an image from June, the image in December would probably have a lot more values that are closer to 0. And then in June, we'd see that bump up as we get the greenness as vegetation starts to grow. Okay, so that's another tool you can use that you may not have known about in QGIS. All right, folks, I just want to let you know about one more thing. That is that on opensourceoptions.com, we should soon be having some free full-length courses that are going to teach you GIS, remote sensing, and programming. The whole idea is to help you become comfortable and proficient with open source GIS and data science tools Those tools are free, they're powerful, and I think there should be free training there. So I'm trying to put together a funding model that will support those free courses. As always, thanks so much for watching and hope you enjoy your day.